Now the last thing I'd like to do in this collection of videos is an elementary example and a slightly more advanced example that we code together in Python. So here's the more elementary example. The world record for running a mile is a total of 223 seconds. How would we represent that particular time in seconds as a certain number of minutes and then seconds left over? So pause, think about this, come up with an answer, and I'll show you how we would write it in code. If we wanted to get to know the number of minutes here, we first need to know how many seconds make up a minute, and that would be 60. So if we perform an integer division on the number of seconds, dividing it up into chunks of 60 that form minutes, and disregarding any partial seconds that are left over, which is why we're using the integer division, we'll get an answer of 3, which should make sense because we're quite comfortable with our multiplication tables, and 6 times 4 is 24, and we have fewer than 240 seconds, so fewer than 4 minutes, but more than 180 seconds, which would be the 3 full minutes multiplied by the number of seconds in a minute. So we've got 3 full minutes of time here in the 223 seconds, and we could find that by doing an integer division by the value that's important to us. If we need to look for the remaining minutes, we want to look at the remainder of when we take 223 and divide it by 60. And again, that formula for the remainder, or this mod operation in Python, is 223 mod 60. The value that that's giving us very specifically is the number of seconds we have minus the number of minutes we have multiplied by how many seconds are in a minute. And when we do this subtraction, we find that there are 43 seconds remaining from those 180 seconds that constitute the 3 minutes. So altogether, the integer division by a relevant number for us gives us the number of minutes, and the modulo operation gives us the number of seconds that remain after we've grouped as many of those seconds as we can into minutes. So altogether, 223 seconds would be 3 full minutes and 43 seconds left over. Let's up the ante a little bit and see how we would code this in Python by saying how many days, hours, and minutes do we have in 500,000 minutes. Part of the reason I chose 500,000 is it's a big enough number that we would maybe want to use a computer to help us with something like this, but we have a relevant number nearby that we know the answer to, so we'll have a way of checking our work for approximate accuracy and reasonableness when we're all done, because since we've memorized the songs of Rent, we know there are 525,600 minutes in a year. So all in all, when we're done coding this, we should have less than a year's time in 500,000 minutes. So let's head on over to REPL and open up a new REPL and start coding. Here we are in REPL, and I've created a variable called total minutes, which is equal to 500,000 minutes. I think the first thing we need to do is create a variable that stores the number of minutes that will be left over that won't evenly be part of any hour or day. Because there are 60 minutes in an hour, if I look at the value total minutes modulo 60, that will tell me how many minutes do not fit nicely into hours. So let's create a variable called number of minutes that is equal to this value. Now the next thing that makes sense is to convert from minutes to hours. Since we now know how many minutes are left over without an even division, we could look at total minutes and do an integer division by 60, and that will tell us the number of hours that is equal to total minutes. And the leftover is stored in num minutes. So let's create a variable called total hours that has the number of minutes that fit evenly into hours as the value that is stored inside this variable. So all total hours has really done is converted minutes to hours for us and thrown away any minutes that do not fit nicely into a multiple of number of hours. From here, we'd like to take the number of hours and think about how many days we have. Because there are 24 hours in a day, we will get the number of days by taking the total hours and looking at the integer division here by 24. This will tell us how many days we have here in total hours, dividing them up into chunks of 24, but num days will disregard any partial hours we may have occupying a day. If we'd like to keep track of the number of hours that are left over after we have this many days, we would use our mod operator. Num hours is equal to total hours mod 24. So just to review, inside num minutes, we first figured out how many minutes we had in this measure of 500,000 minutes that couldn't be evenly categorized into hours. In line 4, we converted from minutes to hours and just rethought of these 500,000 minutes, as many of them as could be evenly packed into hours, we stored that in total hours. We then did a very similar process when we moved to lines 6 and 7, where we figured out in line 7 how many hours were left over that could not be evenly categorized into days. And last but not least, line 6 calculates for us how many of those total hours can be evenly packed into days. So if we want to know the number of days, hours, and minutes that's equivalent to 500,000 minutes, we'll just ask the computer to print these values for us, and we'll print total minutes is num days, days, num hours, hours, and num minutes, minutes. And we'll see if we get something reasonable, which we do. 347 days, 5 hours, and 20 minutes. Remembering that 525,600 minutes is a year, which would be 365 days, this seems like it has a good shot of being done correctly.